In this lecture, we're going to learn a little more about integers in C++. Integers are represented by int in C++. It's what you see on the left here. And they are used to store whole numbers, things like 1, 2, and 3. They typically occupy 4 bytes or more in memory, but in most times it's going to be 4 bytes. So, for example, if you have a variable called age and it is an integer, this is how it's most probably going to look in memory. It's going to take 4 bytes. And I really want to make it clear what a variable is. It is a named piece of memory that you use to store specific types of data. Okay, so here if we have a variable named age, it is a named piece of memory. Age is going to be the name of that piece of memory, and we can store data in that memory. It's going to look like this in memory, but the value is going to be stored in here in binary format. I really hope this makes sense. A variable is a named piece of memory that we can use to store different kinds of data in. Okay, now we're going to look at a few examples of how you can work with integers in your C++ program. You can define a few variables. Here we have one that is going to store the number of elephants we have. You can declare it like this and not put in a value. And if you do it like this, the compiler is just going to put in some garbage value that is really not meaningful for your program. So you see the warning we have here as a comment. The variable may contain random garbage value, and this is something you need to be aware of. Another way we can define integers in our C++ program is this statement here that declares a variable called lion count. It's going to initialize to 0. If we use curly braces like this, it's going to initialize to 0 by default. We can also explicitly put in a value. We can do the same with cat count, and we can use these variables to do operations. For example, we can declare another variable, and it is going to store the number of domesticated animals, and we're going to add up the numbers for dogs and cats, and we're going to store the result of that in our variable that is called domesticated animals. This is something you can do. Another thing that can be problematic is trying to use variables that you haven't defined or declared in your program. That is going to give you a compiler error, and the compiler is basically going to say, I don't know what doesn't exist 1 here is, I don't know what this doesn't exist 2 is, it is not defined anywhere in the program. Another thing you can do is try and store a fractional number in a variable that you declared as an integer. And this is going to give you a warning because fractional numbers are usually bigger in size than integers. And this is going to lose some of your data. We don't really have enough tools to understand this now, but we are going to understand this a little later in the course. But this is something you can do. You can take a fractional number and store that in an integer variable. And we're going to do an example and see how this behaves with our compiler, that is GCC 10. Okay, here we have mostly used curly braces to initialize our variables, but we can also use parentheses, and this is going to be usually referred to as functional variable initialization because we are using parentheses. And this is mostly going to do the same thing we saw in the last slide with curly braces. But when we come to the example here where we are storing a fractional number, this is going to silently chop off the data you have in a fractional number and turn that into an integer. And this is called implicit conversions. But if we go to the last example here where we are storing 2.9 into an integer, this is going to take this fractional number, chop off the decimal point, and only store 2 in this integer. And this might not be what you want, and it is going to happen silently. So this is a really bad way to do this. If you want to do something like this, it is preferable to use curly braces because you are either going to get a warning that this is going to lose you data, or you're going to get a compiler error and the compiler is going to completely stop you from doing this. And again, if any of this doesn't make any sense, we're going to go in Visual Studio Code, play with this, and see how the compiler behaves with these things. We have another way we can initialize our variables in C++. We can use assignment, and we have done this a couple of times in the course, but this is something you can do, and we are going to play with this in Visual Studio Code in a minute. and you're going to see how it works. Okay, by now we have seen three ways we can initialize our integer variables. We can use braced initialization, which is basically using curly braces. We can use functional notation, which is using the parentheses, and we can use the assignment initialization, which is what we have here. Another thing I really want you to see is that it is possible to query for the size of your variable. Here we are trying to print the size an integer is going to take on our operating system and compiler. And if we try to run this on our compiler, it's going to tell us exactly how much memory an integer occupies in our program. We can either pass int explicitly like this, or we can pass a variable name, and it is going to work equally well. Okay, ints are mostly going to take up 4 bytes in your memory, so here we have a representation of 3 ints in memory. If we go from this 0 to this 0, this is going to be exactly 4 bytes, and this is how it may look in memory. One other thing I haven't really talked about on purpose is that there are a few rules you have to follow to name your variables in C++. One of those rules is that a variable must start with a letter like A, B, C, D up to Z, or an underscore. You can't start a variable, for example, with a number. That's going to be a problem. After the first character in your variable name, you can really put in anything. You can put in numbers, you can put in letters, you can really put anything you want, but the first one can't be a number. Variable names are also case sensitive. So if you have a variable called bike account with a lowercase b, and you have another one that starts with uppercase B, these are going to be two different variables, and you have to be aware of this. No spaces or special characters are allowed in your variables. You can use underscores, but you can't use something like plus because that's going to be confusing to your compiler. And these are a few rules you really need to be aware of, and you're mostly going to be fine. The general form for declaring and initializing your variable is what you see here. You're going to pass the type. In this case, we have used int because we are learning about ints. You're going to pass the variable name, and you're going to put whatever it is you are initializing your variable with. Of course, this is braced initialization because it is using curly braces, but you can also use functional initialization or assignment initialization, and it is going to work equally well. Okay, now we have enough information to go in Visual Studio Code and play with us. Okay, here I am in my folder for the projects of this chapter. I am going to hop over in my template project and copy the files that I need. I am going to go up again and go on the project that is called integer types. I am going to go in and paste in my files, and I am going to open up this folder in Visual Studio Code. I am going to close the welcome screen here and open my main CPP file, and I am going to do the usual, take out the things we don't need. To save on time, I am going to put in a piece of code that I have lying on my drive, and we're going to go through it to save on typing time. I don't want you to suffer watching me type this. The first thing we have is the elephant count. This is a variable that is not initialized, so this is going to contain garbage data. It's not going to contain anything that is useful to us. But some compilers are going to usefully put in a 0 because that's a logical number to put in here if you didn't explicitly put a number in here. The second one is using curly braces, and this is going to automatically initialize to 0. The third one is going to be explicitly initialized with 10, and the cat count is going to be initialized with 15. You can try and print these out and see what you come up with after compiling this application. Another thing we have seen is that we can do something like this and put an expression into our curly braces, and the value this evaluates to is going to initialize this domesticated animals variable. And now you should know that this is probably going to take 4 bytes in memory because it is an integer. This is really how C++ works. Each fundamental type has a size associated to it most times. So integers is mostly going to be 4 bytes on your system, and we're going to query this a little later in this video. Okay, let's try and compile this program and see if it actually works. We're going to start build, and you see that the build is successful. Another thing we can do is try and use variables we haven't really declared in our program. And you can guess what is going to happen. If we try to do int new number, for example, and put in doesn't exist, it's a number that doesn't exist, the compiler is not going to know what this is because we didn't declare a variable called doesn't exist. If you try to compile this, you're going to get a problem. You see that we have a problem before we even compile. So Visual Studio Code is this smart. It can analyze our code before we compile it and give us hints to problems that might come up. You see here it is saying doesn't exist isn't defined. So if we try to compile this, we're going to get an error that we expect. It's going to say doesn't exist, doesn't really exist. I don't know what that is. So you shouldn't really do that. You shouldn't try to use variables you haven't declared. This is braced initialization. We can also do functional initialization as we have seen. Okay, another thing we can do is store a fractional number in an int variable, and we're going to see what this does. We're going to try and compile this code. You see we have a 2.9. We're trying to store this in an integer. If we try to compile this, let's try and use GCC. Let's clear this. Let's bring up a terminal and try to build this. We're going to try and run our GCC compiler on this program. It is going to say error narrowing conversion of 2.899 from double to integer. C++20 isn't even going to allow this. So this is a good thing because you might think that you have a 2.9 and some compilers are going to chop this off and store a 2 instead. So this is one of the safe things about this way of doing things. So I am going to comment this out because otherwise our program wouldn't compile. Now that we know how to use these things, we can try to print the values in here. Okay, I am going to put in a piece of code I have lying around on my drive. I am going to remove these spaces inside because it is annoying. Let's do this. And if we try and build this program, it should compile successfully. And if we run it, we should see our numbers. We're going to go in our terminal here and do dir. And we're going to run rooster. And we're going to see elephant count is 1 because this is a garbage value, so it could really be anything. Lion count should be 0, dog count should be 10, cat count should be 15, it is what we have, and domesticated animal count is 25 because we have dog count and we add that to cat count and we're going to end up with 25. This is what we expect. Now that we know how to work with this, we can also try and play with functional initialization. Before I put in my code, I am going to comment all this out because I don't want this to disturb us as we work with our functional initialization code. So I am going to comment all this out and go all the way down and put in my code for functional initialization. And you see here we have a variable called apple. We initialize this to 5. We have orange count, which is 10. We have fruit count. And we have a bad initialization that is not going to work. It doesn't exist. 3 and doesn't exist. 4 don't really exist. So this is going to give us a compiler error. And if we do something like we do in narrowing conversion functional here, this is mostly going to compile. And this is going to chop off data and store a 2 instead of the 2.9. This is something you should really be aware of. And you see the comment here says information lost. This is less safe than braced initializer because braced initializer is going to give you a compiler error if you try to do this. And that's a good thing. So we also try and print these out. So I am going to tidy this up a little bit. And I am going to try and compile this piece of code, run task and build with GCC. The build is going to pass through without a problem. And if we do clear and run rooster, we're going to see apple count is 5, which is what we have in here. Orange count is going to be 10, so this is right. Fruit count is going to be 15 because it is 5 plus 10. And what is really worrying is that narrowing conversion is 2, but we didn't store in a 2. We stored in a 2.9. And because an integer can really store 4 bytes, 2.9 is more than 4 bytes, and it is going to store what it can, and it is going to chop off this 2.9 and only store in a 2. So this is really something you should be aware of. Sometimes this is going to cause problems in your program, and really, if you are trying to store fractional numbers in an integer, please use a braced initialization form, because the compiler is going to stop you from doing this if you try. Okay, so this is really the difference between functional notation and braced initializer notation. Functional notation is not going to give you an error if you try to store something that can't really fit in an int. It is going to silently chop it off and put in whatever it can. And braced initializer is going to give you a compiler error. So this is the difference between these two. Okay, I am going to comment this out as well. And I am going to put the starting comment here. And I am going to go down and show you that you can do assignment initialization as well. I am going to put in my code here because I don't want to type it really. And I am going to print all this out. And we have a bike count variable that we initialize using the assignment notation. Track count is going to be 7. Vehicle count is going to be bike count plus track count. And we're going to be narrowing conversion here, and we're going to see if this actually works. We're going to try and build this. We're going to run the task to build with GCC. It is going to pass through. You can guess what we're going to see if we run the program. Bike count is 2, track count is 7, which is what we expect. Vehicle count is 9, and the narrowing conversion is also chopping off what we have here. So this is something you need to be careful about. Another thing I want you to see is that you can check the size of your variables in memory. So we're going to check the size with size of. And I am going to put in a piece of code to really play with this. I don't want to type all this because it's really self-explanatory by now. We're going to print size of int, and inside we're going to say size of int. And this is going to give us how much memory is really occupied by an int. And we can use this form here by passing in a variable name. Track count is a variable we have declared and initialized here. So if we build this program, let's do that with GCC. The build is going to pass through. And if we run Rooster, we're going to see that the size of int is 4. You're going to see that this is in bytes. And size of track count is 4 as well, because track count is also an integer. So these are all little tools you can really use to know how much memory is really being used and occupied by your program. And this is really all we set out to do in this lecture, to learn as much as we can about integers. Integers occupy 4 bytes in memory for the most part, and we have seen different ways we can initialize our integer variables. We can use braced initializers, which is going to use curly braces. We can do functional initialization using parentheses like this. We can also do assignment notation using a from like this. And we can use size of to check the size of our integer variables. I have to say that these kinds of initialization also work on other variables, but we took the chance to introduce all these concepts using integers. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to start and learn about integer modifiers. Go ahead and finish up here and meet me there.